Okay, in this video I want to do a quick homework example of how we could solve a system of nonlinear equations using elimination, or also known as the addition method. So to begin, notice how we have x squared and x squared here, y squared and y squared. Note that does not have to be the case, but in this case you could solve by substitution by getting x squared or y squared by themselves, but in this case I think I'm going to try the elimination approach. And so I have to choose, would I rather eliminate x squared or would I rather eliminate y squared? And in this case, I'm going to choose to eliminate the y squared. And so in order to do that, I would need the 3y squared to cancel out the negative 3y squared with the positive 3y squared. So that's the first thing I'm going to do, is multiply equation 2 by 3. And if I do that, I end up getting 3x squared. It's kind of hard to see my 3, sorry. 3x squared plus 3y squared. And when I do 43 times 3, I get 129. 129. Okay, so when I combine that with what's above, so just copying and pasting the first equation, sometimes you actually have to do more than that, right? You have to multiply both equations by a number, but in this case this should be good. So just carry over just as it is, x squared minus 3y squared. I'm also going to move the 39 over, making it negative 39 right now. And now when I combine those two equations, that's what the addition or elimination method does, is you now combine them by adding and see what you get. And when I do that, notice what's going to happen to my y squared terms. That's right, they're going to cancel out. So when I add down here, I'm going to get negative 3y squared, positive 3y squared. These two cancel out. But 3x squared plus 1x squared gives me 4x squared. And 129 minus 39 is going to give me 9. In this case, it's going to give me 90. Okay. And, oh, I did make one mistake. Did anyone catch that? I thought this answer seemed too easy. Yeah, what was the mistake I made? If you thought, well, she didn't multiply something, you're correct. That 3 did not get multiplied by the first 3, so be very careful. I wish I could say I did that on purpose, but I was going too fast. So that should have been 9. And then 9 plus 1 would be 10. That's the answer I was looking for. So 10x squared should equal 90 in this example, which then means we've eliminated the y squared, that x squared would equal 90 over 10, or x squared would equal 9. Well, if x squared equals 9, then we know that x equals what? Plus or minus the square root of 9, or plus or minus 3. So your solution set is going to have ordered pairs where x is either 3 or negative 3. Now what you could do at this point is plug in 3 and negative 3 separately, but notice since we're squaring x in both cases, that it doesn't matter if you plug in 3 or negative 3, when you square it, you just get 9. So a little shortcut would be to actually plug in either here or here, x squared, replace it with a 9. And I'm going to choose the second equation to back substitute into because that gives me y squared directly. So when I do just that, let's see what happens. We're going to get, so this is our back substitute. Let me get a marker that works here. Sorry about that. So when we do our back substitution here, we're going to get 3 times x squared, which is 9, plus y squared equals 43. Or in other words, 27 plus y squared equals 43. And then solving here for y squared would equal 43 minus your 27, which is 16. So if y squared equals 16 whenever x squared equals 9, that means whenever x equals positive or negative 3, that gives us that x squared equals 9, right? Then we're going to get y squared equals 16, or that y would be positive or negative 4. So in other words, our solution set, if we wanted to write that out right now, what would it be? Our solution set would be the set of all orders pairs rather, where if x is 3, we have 2 possibilities for y, don't we? Sorry, these markers are dying on me. If x is 3, green, nothing wants to work for me. Okay, if x is 3, then we're going to have a positive 4. If x is 3, we're going to have a negative 4. In other words, I could just write plus or minus 3, plus or minus 4, but I'm trying to be precise for you. If x is negative 3, we're going to have a negative 4. And if x is negative 3, let's scoot that over here, we're also going to have a positive 4. So just to reiterate, if you can't read my bad markers here, we have 3, see if I can get something to write, 3, 4. We have 3, negative 4. So 3, 4. 3, negative 4. We have negative 3, negative 4. And we have negative 3, positive 4. I apologize for those awful markers. So again, 3, 4, 3, negative 4, negative 3, negative 4, and negative 3, positive 4. Those would be our ordered pairs that satisfy this original equation up here. And again, you can always plug them back in to make sure you're right. Well, I hope that's helpful. And again, I apologize for the bad markers. But that is an example of how we can solve a system of nonlinear equations, 2 and precisely, for the possible real solutions, which in this case there were 4 ordered pairs that satisfied it, using, again, the elimination method instead of substitution. All right, if you have any questions, feel free to email me. Otherwise, happy practicing, because remember, math is not a spectator sport. I'll see you next time.